A data challenge a day helps you master machine learning. This is DDC 17 correlation in scipy. It's a little bit more involved, a little bit longer than most of the code challenges. I hope you enjoy working through this one. Here, you want to generate data, correlated data, in a for loop over 25 iterations. Inside each iteration, you generate one variable as normally distributed random numbers with a mean of 0 and a standard deviation of 1. And then you create a second variable, y, that is x, so that imposes the correlation. And then to decrease the correlation value, you add random numbers also with the mean of 0 to y, but the standard deviation ranges in different numerical values inside the for loop over 25 iterations. You start from a tiny amount of noise that's going to create a really strong correlation between x and y, and you increase the amount of noise that you add to y that will decrease the correlation. Then use the scipy.stats function Pearson R to get the correlation coefficient and also the p-value between the two variables. And then you generate two scatter plots that look like this. This one on the left shows the correlation coefficient between x and y. If the p-value is less than 0.05, you see it as a red circle. If the p-value is greater than 0.05, indicating non-significant correlation, then you plot using a red X, like what you see here. Here on the right, you see the p-values. Now, I'm not plotting the p-values directly. I'm transforming them into minus log p. So that means that larger values are smaller p-values. So this is more statistically significant. And the dashed line here corresponds to a p-value threshold of 0.05. So that's the explanation of the challenge. It's a little bit involved, but I believe in you. I know you can do this. If you go to my Substack page, you see this AI generated picture of a horse snorkeling. I don't know why. And you see the full solution down here. And now I will walk you through the solution in code. So we need scipy.stats, we need numpy, we need matplotlib. Here I'm generating, let's see, in this for loop over here, I generate variable x to be 100 normally distributed numbers. And here I generate y to be x plus some random noise. And that random noise varies in its standard deviation from zero point 0.1 to 6 in 25 steps. Then I calculate the correlation coefficient and the p-value, the statistical significance between these two variables, and then I define the marker here depending on the p-value, whether it's bigger or smaller than 0.05. And here I generate the two plots. Here you can see I'm plotting r as a function of the standard deviation, and here I'm plotting minus the log of the p-value as a function of the standard deviation. Takes a while to set up the code, but it's very fast to run. And you will see each time you rerun the code, you get slightly different results, but the main pattern is consistent every time.